So today we're in 6.6. We're learning about scale drawings and scale models. All right, in the first example, we're given a map of a city that was built in Mexico hundreds of years ago. They say 2,000 years ago. And we've got a scale drawing. You'll want to look in your books on page 300 at the map. Okay, look at the map on page 300. Okay, so we have this Mexican city, and on the bottom of the map, it gives us a scale. What is our scale? 1 meter. What is it? Not meter. What is the cm, guys? 1 centimeter for every 200 actual meters. So this map is a very small version. 1 centimeter, if I were to measure it on the map, stands for 200 meters in real life. All right, that helps me to be able to find out either the measurements I don't know of the scale or of the true dimensions. We'll see in example 1. All right, so example 1 says, on the map, the center of the pyramid of the sun is 4 centimeters from the center of the pyramid on the moon. So which dimension is that? Is that on the map or is that the actual? What does it say?
On the map.
It says on the map. So I'm going to write my original scale, which it's already told me is 1 centimeter over 200 meters. All right, so there I've set the order for how it has to be written in the second ratio. Now it gives me the dimension of 4 centimeters. So in order to make sure they match up, does 4 centimeters go on top or on bottom? Would it go on top or bottom in the second ratio? 4 centimeters. Why would it go on top? Because I've got to compare centimeters on the top of both ratios. It's got to be the same on both sides. So I've got 4 centimeters over, and I don't know how many meters that would be. All right, so when I'm solving these, I'm not going to worry so much about my labels. I'm just going to do my cross products. So I get 1x equals 800 meters. How do I know it's meters and not centimeters? Because of its placement in the ratio. Because I know that I'm comparing centimeters over meters, so then 800 would be meters because it has to compare on both sides. Okay? 800 meters. Any questions about using a scale model to find the unknown dimension? And guys, we can do this in reverse. Maybe it gives us the actual dimension. We have to find the model, so then our variable goes on top. Okay? We just solve it the same way. Now I want you to do one. All right, so now it's the same type of example except just different dimensions. Now on the map, the center of the sun is 12 centimeters from the center of the moon. Okay, so let's set up a proportion and solve to see what would be the actual distance. If it was 12 centimeters away on the map, how far is it really apart in the actual distance? Go ahead and try to solve that. So I use the same scale, which is 1 centimeter to 200 meters. Now I'm just comparing it to 12 centimeters, and I don't know how many meters. All right, so now I've got x equals 2,400. How do I know if it's meters or centimeters? Yeah, because I'm looking for the actual distance, right? I need the actual distance. I'm solving for the denominator, so that's how I know that my label is meters. All right, any questions? So if it was 12 centimeters away on the map, that's how far it actually is away in real life. Any questions on example 1? Anything? Okay, so now let's look at example 2. In example 2, now I'm writing my own scale. Okay, so I'm not necessarily solving for anything. I want to write the scale given the dimensions in the problem. Okay, so this is a floral carpet example. All right, so before actually making this carpet, the designers make detailed scale drawings. So suppose the actual carpet is supposed to be 40 meters wide, so the designer creates a scale drawing that is 20 centimeters wide. What is the drawing's scale? What's important that you remember is that the scale needs to go on top, okay, or the drawing needs to go on top. The actual goes on the bottom, okay? So if I'm comparing the drawing to the actual, what number goes in my numerator? 20. And we've got to put our label, centimeters. What is going to be the actual? 40 meters. Okay? And that's going to be 1 centimeter over 40 meters. And just like with any ratio, we can write it multiple ways. We like to write scale drawings with a colon. Or it could be 1 centimeter to 40 meters. Okay? That would be fine. Now, on your homework tonight, it's going to tell you to write this scale without the unit label. Well, let's look at it. Oh, sorry. It's 1 to 2. It's 1 to 2. Whoops. I don't even know why I'm thinking 40. I forgot to reduce it. Okay, so it's 1 centimeter to 2 meters. Okay, so, or that's 1 centimeter to 2 meters. But on your homework tonight, it's going to say to write this without the scale or without the unit. Write the scale without the unit. So what it means is, well, if I just dropped it off, it looks like it's 1 to 2, but that's not a true comparison because it's not the same unit. So I'm going to take the larger of the two. Which one's larger, centimeters or meters? Meters is larger, and I'm going to convert it to centimeters. How many centimeters are in a meter? 100. So if I wanted to write this without a scale or without a unit, I keep saying scale, without a unit, I would say 1 centimeter to how many centimeters are in 2 meters? To 200 centimeters. And then technically I can drop my label, so it's going to be 1 to 200. All right? So if I want to write my scale without the unit, I need to convert them both to the same unit, and then I can drop my label. All right, you have a section like that on your homework tonight where you do that conversion. Okay? So that's it for example 2. Any questions? Any questions on it? All right, example 3. Okay, in example 3, now we're finding the dimension of a scale model. Okay, so in this case, I see the scale. But what do you see that's missing in this scale? The units, the labels. So since there are no labels for my units, I am going to assume that it's the same unit because that's what we just learned. If there's no label, it means that I'm comparing numbers that are in the same unit. 1 to 52. Now here we have to use a little bit of just, inference, or we're assuming that 1 stands for, what do you think it stands for, the drawing or the actual size? The drawing, because it's always going to be a very small portion of what the actual is. And 52 is actual. So when I'm setting up my proportion, the top needs to be the model, the bottom needs to be the actual. So when it says that the model has a scale of 1 to 52 and the space shuttle has a wingspan of 78, find the model, which side of the ratio does my variable go in? Top or bottom? Top. Why top? Because I don't know the model. And it's the same, it's got to be the same thing on both sides. 1 is the model, so the unknown model length goes on top. 78 goes on bottom. And now I do my cross products and solve. The unit label is not necessary because I'm comparing everything in the same unit. All right, so I end up with 52x equals 78. divide both sides by 52. And x equals what? 1.5. And I know that it's in feet. Okay? I know it's in feet. Any questions on this one? Haley?
Does it matter if we put it in a decimal or a fraction?
It does. Think about it, if you were plugging it back into the original, you wouldn't want a fraction over a fraction. Okay, so that's why we have it as a decimal. It's a great question because you have a couple problems on your homework tonight that are decimals. All right, any other questions? Jonathan?
So, how did you get 1.5 feet? Why not
Well,
inches?
because of 78. And I know that the scale is the same unit as well. Okay, so if it said 1 inches to 52 feet, then yes, my answer would be in inches. But because there's no unit, I know it's the same. And since the actual is in feet, I know the model is in feet as well. Okay, great question. Cole?
If you wanted it to be in feet, wouldn't it be like 18 inches? Or inches, I mean?
If you wanted it to be in inches, then yes. Okay? All right, guys, that's everything you need to know for 6.6.